hello, and welcome to the show. It's JP's product pick of the week, and it's that time again. I'm JP, and today we're going to look at a cool product that I like an awful lot. And before I do that, though, I'm going to jump all out of order and send you to the product page first. So, as you can see, there is a breathtaking 50% off. If you head to the product page, you can just use that QR code right there or this URL. It's going to be product number 4756. So head on over there. In fact, let me jump over there and... All right, I'm back, and hopefully that fixes the sync issue. So if you want to check this out, this is the product. And right now, I'm going to refresh my page. You'll see it is half off. So it is the LTC4311. It's an I2C extender and active terminator. I'm going to tell you all about it, but one thing you can do is watch the show from right within inside the product page right there. Click on that link, and you'll be watching this very video. So now let's get back to it in real normal time. So what I'm going to do is actually have Lady Ada tell us all about this product. So let's jump to the new first.
Okay, this is going to be, I think, a very popular one for the people who need this kind of thing. You have an I2C connection, and you have maybe like 1 foot of cable. But what if you want an I2C connection that goes 100 feet? What do? I2C normally isn't designed to handle cables that are 100 feet long unless you have one of these LTC4311 active terminators. This thing is really cool. So this is what your I2C normally looks like, right? You've got the pull, there's an active pull down. So that's the straight line of the sawtooth. But then when a device wants to release the bus, because remember it's a shared bus system, the weak pull-up is what brings the signal high. And if you have a very long connection, that capacitance coupled with the resistance of the pull-up creates that RC constant, which is what you see in the sawtooth wave. There's also some resistance of the cables as well. So you can mess around with the resistance, make the resistor smaller, so that will reduce your time constant and make your sawtooth wave a little bit less sawtoothy. But at some point, you're just fighting the capacitance of the cable, and you can't make the resistor any smaller. That's where the active terminator comes in. Plug it in, and this chip will automatically detect that the SDA and SCL pins are starting to come up. You can kind of see it curve at the beginning of the sawtooth. This chip will kick in and dump a ton of current in and pull that line up solidly all the way, so you get a nice square wave. So if you look at this demo here, what we've got is a trinket connected to an OLED display and then the active terminator below it. And then on the right, we have the I2C pins connected through an Ethernet cable that's 100 feet long to a BME 680. And when we, as long as you just set the I2C frequency to about 100 kilohertz, which is kind of standard on Arduino anyways, you're able to communicate with all 3 devices, even though there's this 100-foot cable. So this is a perfect perfect add-on to your I2C devices when you have long sensor distances. It's plug and play with stemma. Just put it at the beginning of your chain. If you have questions about the capacitance and the current draw, whatever, check the datasheet, because it doesn't act as a I2C device. It just sits on the bus and just helps it along. It's a little helper.
Almost fooled myself. There we go. I'm going to grab one myself. So let me head on over to my mystery cabinet and pull one out. Yes, so that's it right there. That is my product pick of the week. It's the LTC4311 Active I2C Extender and Terminator. So this thing, as Lady Ada said, is really useful when you want to run a sensor or a screen or any of our STEMMA QT peripherals that we have, or any I2C device, honestly, a long distance from your microcontroller. Because I2C was not designed to run long distances, it was meant just for a board really originally, we're really pushing things by running it across long lengths of wire. And as you saw in that demo, we end up with some slew going on in the pull up and pull down. And so this corrects that. This allows it to run across a long distance. And so for a bit of a demo, what I wanted to do is show you what I have set up here. So I have let me go to my down shooter here, and I'm gonna actually, let's go to this view here. Okay, so behind me there on the wall, you can see I've got a red target there so we can see it. And sitting there is one of our little STEMMA QT light sensors. It's the BH1750, I think is its name. And that is running over about a 30 or 50-foot length of Cat5 cable, Ethernet cable, which is 8 wires, twisted pairs. So that's running to the sensor back there, and then it comes up into what you see in this down shooter here. If I move this over, the Ethernet cable is plugged into a nice little RJ45 adapter that we have. And then what you'll see I've done is I've actually paired up. This was Lady Ada's suggestion. I'm pairing up, since there's 8 wires in there, 8 conductors, and I2C just needs 4 connections. I'm doubling up each of those just to increase my, my signal quality. And so you can see I've got ground, power, data, and clock. And then those are running to our little Terminator here, the LTC4311. And then that's running into a little QT Py. Now, if I show you what's going on over in Moo here, you can see I have a really simple piece of code, and this is just querying every 10th of a second. It's querying that light sensor all the way back there at the back of the shop and asking for the light value in lux. So what you'll see is I can actually keep an eye on that graph, and I'm going to use my phone to turn off the lights here. So now you'll see we're down to 6.25 lux, so it's almost pitch black back there. Now I'm going to take a flashlight, a real super bright one, and you can see as I point that back there, we can graph going from about 6 lux up to about 200 or so, and then I can put the lights back on, so I'll flip that right there like that and bring the lights back up. And that's kind of a fun way to graph that and look at that, kind of a neat demo. But you can imagine if you're into STEMMA QT sensors, if you're using moisture sensors, pressure sensors, temperature sensors, light sensors, all of those things, it may be that you want to centralize where you're reading them and run them out somewhere distant. Let's say I'm in my workshop here and I want to be checking the sunlight outside or the temperature. This is one way to do it, is use these really cool I2C active terminators that really push the I2C beyond the bounds of its original inception. So let's see. This, as you can see, I'm gonna take a look at the code here. It's dead simple. I've just got essentially nothing changes using this Terminator. My code is identical, so it's not like I have to talk to it like it's an I2C device. It just goes onto this, this bus and gives us a boost. So my code is the same as the sort of typical demo code for the BH1750. I'm using that over I2C, as you can see, which is necessary for this all to work, and then I'm graphing that in the plotter inside of Moo. So that's really straightforward. And the other thing that we can do is have a look at, I mentioned the product page before. If we take a look, here it is. Like I mentioned, right now it's half off, so go ahead and get yourself one. In fact, I'm going to refresh the page here. I can see we've sold 2 at least since I refreshed that before. It's fun to watch the in-stock ticker. If you take a little scroll down in this page and head down to the Learn section, you'll see we've got a Learn guide. They'll tell us all about the sensor, how to use it, the pinout, There's some of those graphs of the oscilloscope before and after adding the booster. We're getting a better square signal and a greater voltage across I2C. And if we click on pinouts here, you can see the I2C pinouts that are set up on here. And there's also a new page that I just added. If you head to the Ethernet breakout usage, this was just since I built this, Lady Ada asked me to include a little how-to, because if you are making one of these, you may want to do a similar thing to what I did, which is just simply take some solid core hookup wire, slip the insulation a little bit, bend it into a U, like a little staple or a jumper, and insert those into the cables. And then I'm just going to solder some cable that I split, one of these connector cables, to use just the stemma QT end. Solder that onto those little staples that I've got there. And then I remembered to actually put some heat shrink over those before connecting them, so that you can get a nice little connection like that. So that's what it looks like on either end, and then we just plug in our Ethernet cable into that, and off we go. And let's see, the last thing I wanted to do was show, if you go to the downloads page of this guide, you'll see we have the schematics for it, the CAD file, and also there's a data sheet here. If we head there, there's the data sheet from Linear Technology. And I'd like to stop for a moment and point out Linear Technology has a super cool logo. I love their typeface there, very Art Deco. So Linear Technology up in Milpitas, California, are the creators of this chip. You can take a look at the data sheet here to learn more about the operational principles, the characteristics of it, some applications. They're saying such as notebook and palm top computers, portable instruments, battery chargers, industrial controls, TV video products. And there are also some ranges there for operational range, for temperature and voltage and so on. So I think that covers it. This is, like I've said, a really terrific device if you are into using these stemma QT boards. And don't forget, we've now got 50 or more. I think we got quite a bit more than 50 of these stemma QT boards. The stemma QT boards all feature this nice little SparkFun quick connector, QWIIC. The quick connector is that format of I2C in that pin order, in that tiny little JSTSH connector. And as you can see, here's just a part of my growing collection of them. But they're great for plugging in. You can daisy chain them as long as you don't overlap any of the I2C addresses. And now with our little friend here, the LTC4311, we can boost that bus and run our I2C over longer lengths of wire than anyone ever imagined. So that's my product pick of the week. It's the LTC4311. And I'm going to go ahead and pop that onto my stemma QT board of goodness, except I'm running out of connectors. Let's see, where'd they go? I've lost some of my my little Lego board connectors there. There's one. I'll reuse this one, which I just kind of broke. So that is it there, the LTC4311. We'll put that on the stemma QT board of goodness, slightly crooked. Hopefully it doesn't fall off. And that's going to do it. That is my product pick of the week, and I will see you next time. Thanks, everyone, and don't forget to head on over to the product page there, where you can pick up one of these for half off right now. So you've got just a few more minutes to do that, and then it's going to go back up to full price. So go get yourself one or two. All right, thanks, everyone. I'll see you next time. Bye-bye.